Hi, good morning. Welcome to this morning or afternoon's webinar featuring Chris Goodman at Coventry and learning how to fix some chronic MSTP issues that Chris had at his university. Today, what we have going on, we're going to learn a little bit more about Coventry University and a little bit about their size and shape and what they're all about. We're going to go over the network issues and challenges that Chris came across in one of his buildings. We're going to look at how he successfully pinpointed the source with some challenges, of course, and how Visual BACnet helped along that troubleshooting process and how it helped speed things up and get it resolved. And then there'll be some time for questions and answers. All right, well, let me introduce you to Chris Goodman. He is a Senior BMS Technician, Chris, at Coventry University. So he's been there for quite a few years. I'll let Chris introduce himself and tell us a little bit about your university, Chris.
So, yeah, good morning. Thanks, Ryan. My name, as Ryan said, my name is Chris Goodman. I'm the Senior BMS Technician for Coventry University. Coventry University's main campus is in Coventry city centre in the UK. We've got about 50 buildings on site there, with a good mix of academic and student accommodation. We also have campuses throughout the UK. So we've got one in Scarborough in Yorkshire, we've got two in London, and we've also got one in Poland now as well, with about 25,000 students. BMS-wise, the BMS team consists of myself and two other members of staff. So we've got our apprentice engineer and a BMS operative, so pretty small in-house team, and we're supported by our contracted maintenance firm, which is SSE. From a BACnet perspective, we have over 400 Siemens controllers throughout the system, and currently just over 1,100 BACnet devices integrated into that system. 90% of devices are IP, with the rest being MSTP, and we've got about 95% coverage throughout all the campuses. And all of the devices are integrated into our Desigo CC system, consisting of about 10 different servers.
Wow, that's pretty good. Interesting site. That doesn't leave with a lot of manpower, but it's why don't you run us through a little bit about what you were seeing with your MSTP issues and challenges?
Yeah, sure. So we were looking to move from a reactive maintenance to a proactive maintenance, and looking to get as much data from the systems we've got available as we can. And this one particular area, this boiler house, was giving us huge problems. The data was just completely inconsistent, or devices were online or then they were offline. It was completely unreliable. And as far as moving forwards to integrating this system into a CAFM software to pass on to technicians, it was completely unreliable. And if we couldn't rely on data from here, how could we rely on it from elsewhere? It had the potential to throw this other project into a bit of jeopardy.
Interesting. Okay. So what was that impact like on your overall system performance, just your day-to-day runtime?
So while the impact wasn't hugely notable for the devices running, like for the pumps, etc., because we do tend to use traditional hardwired signals for those, the impact was potentially more, relying on the data for use in other applications. That's where the reliability was falling down for us. We couldn't rely on the data we were receiving.
Okay, great. And at that point, I believe you used Visual BACnet to bring into your facility and started looking at some other issues. But for today's problem, we're going to look right at your MSTP issue that you came across. So I believe it was a year and a half you were running with Visual BACnet, cleaning up your site, and then you started to focus on this one. So tell me a little bit about what happened in this particular building with the MSTP problem you were seeing.
So as we'd narrowed it down to this particular MSTP trunk, and we'd seen these devices dropping online and offline, we'd obviously gone back over the cabling and reviewed the cabling and how that was installed. We'd actually gone to the extent of having the MSTP cabling replaced through the network to make sure that was correct, because originally it wasn't quite up to specification. So once we'd done that, replaced the cable, we were confident that the cabling was correct. It was all terminated correctly. The grounds were only down at one end. Screen was consistent throughout. All those good things that are standard things you need to make a correct.
Okay. Yeah, and MSTP can definitely be challenging at the best of times. So it's excuse me. So a little bit about the installation. So you obviously had an IP network going to a BACnet router, and then what kind of tools were you using to try and troubleshoot this?
So I think, like you mentioned, we were fortunate. We had Visual BACnet, a capture tool, running on this system. So we were able to take a snapshot and analyze it in near real time to see the effects we were having on the system. So we could make a small change. We could break the network. We'd drop devices off, bring them back online. Each time, run maybe just a 2-minute capture, just to see, has this made a difference or not?
That's interesting. Why don't we take a look at one of your early captures and see what kind of data that threw out? So it looks like one of your early captures that you presented, it had a health score that was pretty low at 42%. But there's a lot of red X's over here on the right-hand side. You can see some of the erroneous data. So there's definitely something clearly going on in this network. And once you saw this data, what was the next step? Aside from breaking the network, is it a kind of a combination of breaking the network, getting another Visual BACnet, another Wireshark file, and start piecing it together at that point?
So yeah, like you said, once you start seeing this data and we knew it was bad, it was a matter of breaking the network down. Fortunately for us, we had a couple of devices right next to the panel. So that was quite easy. Cut the network there. Let's get these first 2 devices online. Can we get these to communicate? And once we got those communicating correctly and reliably, we were then able to break it a little bit further down. Let's bring another 3 or 4 devices on, see what happens, and just keep moving through the network, just isolating chunks, running a small capture, maybe 5 or just even 2 minutes perhaps, seeing what data we get back. And then eventually we started to narrow down. It became clear that there was a couple of pump sets, which every time we connected these, all the pumps were bringing it down. Again, fortunately, being as we were in a small kind of boiler house, we were able to throw a flying lead from the panel out to these pump sets and just test them in isolation to see which one of these devices are giving us the problems.
Okay, interesting. And you can see here from some of your testing results that you broke the network down. Looks like you got rid of devices 1 to 12, so breaking the network in half, getting another scan. Clearly you can see here the health score went up. So headed in the right direction fairly quickly. And that process, aside from the physical labor, but sending you in the right direction, can you tell me a little bit about that?
Yeah, I'd say that process and taking that approach saved us a lot of time. Once we got on top of the issues, we probably took us maybe a day or 2 days to start focusing in on where the problem was.
So once you got a little bit further down the path, and so once you isolated the pumps, was that the only 2 devices you had on the network, or did you remove them from the network and then this 86% score was the final result?
I would have to see how many devices that one's got. Seeing in total, I think that's with everything back together. But once we isolated that down, it was these pumps. We were then able to go down even further and just connect one pump onto the router with Visual BACnet and take a quick capture with that one device in isolation. And then from there, once we knew whether it was good or bad, we were able to take the interface card out of a known good one, put it in the known bad one, and really just help narrow it down. Was it the pump interfering with the card, with its MSTP card, or was it the MSTP card that was bad? Unfortunately, we got to the point where we found it was just some MSTP cards that were bad, that just seemed to be flooding the network with garbled data. And yeah, once that's the 86%, once we got them all replaced.
Right. That's fantastic. So knowing that this was bad, was this the first time that you noticed that it was bad, or had you tried to fix this network in the past?
No, it had been ongoing for some time. We knew it was bad. And like I say, beforehand, we thought, well, maybe it's cabling issues. There wasn't a reference cable within the cabling. It was just 2 cores. The screen had been used as a reference and it was connected wrong. So that was the first thing. Get that cable replaced. Let's get it to a known cable, to a known good standard. But from there, we still knew it was unreliable. So the next steps were to go through this process and really dig into it and see what was happening.
So in summary, you started to replace and correct elements that you could trust and start the elimination process from there.
Yeah, for sure. Yeah.
That's fantastic. Yeah, MSTP can always be a challenge, and it's always physical in nature to try and break it down and look at all the different components. So was the system operational at all? Were the pumps still working? Because you said you hardwired them for start stop and all the control.
Yeah, all the controls were hardwired. So operationally, we were fortunate in our application in that it didn't affect its day-to-day operation. They still functioned and doing the job they were needed to. But if this had been some room control units or some fan coil units, it would have been a whole lot worse, because we'd have had people shouting at us saying, the fan's not on, it's too hard, it's too cold. It could have been a whole lot worse.
Right, and in some ways it goes a little bit undiagnosed if things are working, except it doesn't really represent itself in the software.
Yeah, yeah.
What was your Desigo software showing? You did mention the devices are online and offline. Is that peer interrogation of the device, weird graphic data?
Yeah, I think from memory, you would go look at a graphic to see what's the run hours of this pump or what's the current pulling, and it would just be zeros. There'd just be no data there, and a load of alarms against it because it can't pull that data back, and the objects were in alarm. So it has the other effect of in the head end software, it gives us hundreds of alarms, because every time one of these objects can't be read, it goes to alarm. So from a housekeeping point of view, it's good to get these problems resolved just to keep the number of alarms on the system down.
Something manageable, absolutely. I want to go back to how Visual BACnet really alluded to where the problems were. So as anyone knows, in MSTP networks, if the data is not very clean, then you get a lot of erroneous data. You could see it in the oscilloscope, you could see it in a meter, you could see odd data with Wireshark itself. Since you already had Visual BACnet in place, did you look at the raw Wireshark data or just skip that step?
Yeah, no, we didn't use go down the Wireshark route, because we had Visual BACnet and we'd been using it for some time. We went straight into using Visual BACnet to help us fault find.
So one of the unique features that Visual BACnet does apply is, if you were to take an oscilloscope on this wire, you would see these numbers, right? These are crazy. These are all in milliseconds, right? So we know that data traveling in a MSTP network is not going to take 187,000 seconds to travel throughout the network. So these are clearly erroneous data, which is being presented by the data that's being captured. In an oscilloscope, you would not see a nice, clean 1-0. You would see more of a shark's tooth than the same thing. So having the ability to get Wireshark data and showing erroneous data, as you can see in the summary screen as well, that's pretty clear that there's issues right off the bat. So the next step, obviously, is once you have this, you need to start pinpointing hardware and starting looking at the network directly. Now, interestingly enough, once you start breaking the network apart and get another quick capture, that's part of your verification process. This step was fairly quick, correct?
Yeah, for sure. Yeah.
So because you were already capturing and already on the network, it should be as simple as unscrewing one of the wires, hit the next capture, analyze it instantly, and move on to the next step.
Yep, that's it. Just split the network wherever we chose to, drop out the outgoing connection to devices downstream, go into the web browser of the capture tool, drop it down to its minimum time, just start it, let it go for 5 minutes, wait for the file to upload, and see what results we get back.
That's fantastic. Yeah, I'm really glad it helped in that way. Is always getting the data and finding a way to test it to see if the data flow that you have is still correct or is still presenting issues. Assuming you only had your Desigo CC server running, do you think if you cut the network and then interrogated the devices that you would have found it in the same fashion?
I don't think it would have been as simple. Yeah, I don't think it would have been successful just relying on the management station. That would have been a lot harder, I think. Yeah, because I think because even if we had have got it working to a state, we wouldn't have known, well, why was it broken? What was the cause? Here we can see the results coming back in. With using the management station, it's either working or it's not working.
That's right. That's right. And it's, to be honest, the management station is there for a different purpose. Yeah, that's absolutely fantastic. So here in the Visual BACnet data, we do break apart many different things of showing where different disruptions are, how the token's being passed, how the length of that time is being deployed. So it's very easy to diagnose MSTP networks in many different fashions, right? Whether the token's being passed cleanly from device to device, whether it's got some erroneous times in there that don't make any sense. It will show you if the token's being held for too long. So in things like you're trying to gather too much data from the network, it's a very powerful tool for all of your MSTP networks that exist. That's I'm really happy that we were able to help and guide the process along, Chris. It's we know how much manpower, how much labor, how much time MSTP networks can take, and it's not always feasible to go get an oscilloscope, bring it to site, and then understand the data that you're looking at. So
we knew we should be able to solve it with Visual BACnet because we'd had an instance before where we had a duplicate device ID on site, and which was highlighted within Visual BACnet, so we were able to jump on that pretty quick and get that resolved before it gave us too much headaches. So we knew it was a good choice.
it's fantastic. Really appreciate that. All right, I think that concludes the data portion here of how Visual BACnet helped Chris at Coventry solve some of those MSTP problems. They can definitely be challenging. They can be labor intensive. If anyone has any questions out there, I'd be happy to answer them. You know, in the course of 2 weeks, looks like Chris got everything fixed up, nice and clean. Here's a bit of statistics on how the data went so far. You can see the progression of the starting the investigation and working the way through. And at this point, it's nice and clean. And now one of the advantages, Chris can sit here and he can watch and he can set an alert inside of this particular network and have the data of if those cards fail again, you're going to know right away. Right, you'll see the network health score drop, and then you'll have a pretty good idea of what the information is. So one of the questions from the crowd was, there's the capture tool that was used, that Chris was using. It is one of the capture tools that Optico does provide. It's a capture device that captures Wireshark data along with the scheduler. So Chris has installed it, and it sits there all the time and continually provides data in a stream to Visual BACnet. So that's where he can set up a capture either once a day or every hour. You can fine tune how long it captures and when. And it installs into the network simply by tying into the main MSTP trunk and then providing an IP connection to get the data out through to the cloud where the data is analyzed. So it's a fairly easy install. Chris, you've deployed now, I want to say 25 of these capture tools in your facility?
Yeah, that sounds about right. And what's been nice for us, the routers we use, the MSTP routers, they've actually got a twin network interface on them. So I'm able to use that second port to plug the capture tool in. I don't have to go to IT and give them a load of money to install me a second IT port. I'm able to use what's on the router already.
Oh, that's fantastic. And the power was all there.
I've actually, yeah, I've deployed them using PoE, actually, Power over Ethernet. I've found a adapter to power them that way. So again, I haven't had to install separate power supplies for them either. That's
fantastic. That helps a lot. And they are DIN rail mounts, so it's very, very quick. You don't have to worry about sticking it anywhere. If you've got a panel already that's sitting on DIN rail, it's a simple click and away you go. And we have one more question. How long does the file take to upload and process? So the file itself, once we take the file, it gets uploaded right away. And depending on the size of the file, it can process fairly quickly. Typically in MSTP, that file is going to be 10 megs, maybe 15 megs. So we're talking less than a couple minutes for you to get actionable results. So by the time you do the capture, come down off the ladder and walk to your laptop to go see the data, it'll be there and ready to process. Fantastic. Any final questions? Great question. There's another question here. Is Visual BACnet running on the entire campus or just the MSTP network? Chris, do you want to take a shot at that one?
Yeah, sure. So it's pretty much the whole campus. We have individual devices on our MSTP trunks. And then on all of our all of our servers, we have the software capture tool installed. So yeah, we're capturing all data from campus.
That's fantastic. So when Chris mentioned the software capture tool, there is one that's Windows-based that installs directly on the server, and it monitors all the data coming in and out of the network card. So it's a very centralized piece that gets the bulk of traffic that's already on your network. The MSTP devices are, once you start discovering more issues in the network, you can work your way down to get more granularity. And we have one more question here. How many features this Visual BACnet software has? Is it one license package, or do you have to buy multiple licenses? The features are fully unlocked once you do the package. You buy one license per user that's going to be on the system. In Chris's particular case, he's got an enterprise version, so his entire staff can run the system without limitation. So there's variable licenses to fit your needs. And then another question here. You mentioned you use Siemens. Does it work on other vendors? JCI, Metasys, any others? Visual BACnet itself is vendor agnostic. So all we look at is BACnet data. And it doesn't matter which vendor it comes from. So whether it be Delta, Trend, Siemens, JCI, Honeywell, Schneider, and there's over 1,040 now, I believe, BACnet vendors that have BACnet vendor IDs. And this software will work for all of them. We look at the application of how BACnet's being applied and look at the corrective measures in that respect. I think we have time for maybe one more question. Other than that, we will end it here. And I really want to thank everyone for their time. I really appreciate you attending the webinar, and I really hope this was insightful. For any more information that you want to learn, there is a free trial sign up on Visual BACnet. And if you go to optigo.net, looking at our products, you can find the links to those. Other than that, definitely feel free to reach out to us. Chris, thank you so much for giving us the information on your site. Really glad we could solve your problem in record time. And thank you everyone for attending.
Thank you very much for taking the time to watch our video. If you'd like to see more from Optigo Networks, you can do so by clicking here, or subscribing up here. Thanks very much.